why attribute control charts fail and how to make them work for you. Send me an email if you'd like for me to send you a copy of these presentation slides and recording, which contains links to the reference metric reporting app, videos, articles, and books. Have you seen out of control signals from a control chart and cannot find a reason? You're not alone. Wikipedia states, in statistical quality control, the P-chart is a type of control chart used to monitor the proportion of non-conforming units in a sample, where the sample proportion non-conforming is defined as a ratio of the number of non-conforming units to the sample size. Let's examine when a P-chart is appropriate. From the continuous or attribute data decision point, we would select attribute. From the defects or decision point, we reflect defectives. That is, we're considering that a unit is defective or not how many defects that may exist in the unit. A constant sample size is our next decision point, which would result in a P-chart. Now let's examine a P-chart. What's your conclusion from this P-chart? Is there a customer problem? What action, if any, should be taken? One would typically state that the special cause events beyond the upper and lower control limits, that's UCL and LCL limits, should be investigated and resolved. Another data analysis indicates that this process is stable and has an approximate non-conformance rate of 2%. If this non-conformance rate is unacceptable, there's a need for process improvement. How can this process stability statement be true? Meet 30,000-foot level reporting. Unlike a P-chart, this upper and lower control limit are calculated from between subgroup variability. That is, 3 times the chart sampling standard deviation. Now this is a big deal, which I'll discuss more later. When a process is stable, there's a prediction statement at the bottom of the report for 30,000-foot level reporting. If a prediction statement is unsatisfactory, there's a need for process improvement. Traditional P-charts can lead to much firefighting, high level, that is 30,000-foot level, common cause variation, as though it originates from special cause variability. Benefits of 30,000-foot level reporting over traditional control charting. Control charts are to identify out-of-control signals for timely actions by way of upper and lower control limits. Control chart, UCL and LCL values are mathematically 3 times the sampling standard deviation from the mean. Mathematically, the sampling standard deviation per P chart is determined from within subgroup variation, calculated from the binomial distribution. It is important to understand that for P charts, between subgroup variation has no impact on UCL and LCL values. From a customer's viewpoint, differences between work shifts, days of the week, machines, and other similar factors that occur between subgroups are potential sources of common cause variation, which customers do not care relative to the quality of the product or service that they receive. For a P chart, if there's between subgroup variation caused by customer viewpoint common cause factors, many out-of-control signals can occur. Control charts do not assess how well a measurement meets the needs of the customer, which 30,000-foot level reporting does. For your data set, you can create a 30,000-foot level report with a free 30,000-foot level app that is available through the link that's shown. I'll later demonstrate how to use this app. Now there's a book that describes the mathematical explanation of benefits of 30,000 foot level reporting over traditional control charting. This book is Integrated Enterprise Excellence Volume 3. In particular, chapters 12 and 13. This book is available on Amazon. There's also an article that describes mathematical explanation of the benefits of 30,000 foot reporting over the traditional methodologies. I'm going to show you how to get access to that article through our website. The website is www.smartersolutions.com. You then go in and hover over resources, and then you pick Forest Favorites. Under Forest Favorites, you'll see a lot of articles. The one in particular that I'm going to focus on for this session is P-chart issues in resolution. If you're clicking on this link, what you would see is a page that looks like this. I want to scroll down on this page, and if you did that, you would see the two mathematical relationships shown here. Now, the upper snippet shows a P-chart, and the bottom snippet shows for 30,000 foot level report. Now, notice how the lower control limit is P bar minus 3 times the sampling standard deviation, which is P bar times 1 minus P bar divided by N. So this is within subgroup variation. Variation between subgroups has absolutely nothing to do with it. Now, think about what happens when N gets large. What's going to happen to the control limits? They're going to get very tight. They're going to get small. Therefore, the good likelihood that you're going to see out of control signals, because basically in most real life situations, the data that we experience violates the binomial distribution consistency between subgroups that are considered in P-charts. Now, if we look at 30,000 foot level reporting, we notice that we got 2.66 times the average moving range, which is basically 3 times the sampling standard deviation. And notice how you got moving range, where it looks at the data points between adjacent subgroups. So now you can see mathematically the difference between these two different charting methodologies. I'll now demonstrate how to use an access of free apps so you can easily create 30,000 foot level reports for your data. So if you went to the web page smartersolutions.com/free-app, which you would see is a page that would look like the one shown here. Next, what you do is you click on the link to access a free app, you register for the use of the app, and then you would submit the completed registration form, then log into the app. Once you do that, you'd see a screen that looks like the one shown here. The green tabs provide much useful information, instructional videos. The example data set on the far right-hand side provides a list of the 2-book series data sets, which is shown on the right. From this listing, a data set can be downloaded so the app can create a 30,000 foot level report for the chosen data set. So these 2 books shown on the right-hand side are written as a novel. We've got 4 golfers, and they go through various business situations and strategies they have in their various companies. I think you could find that very interesting. And also, these books are available in audiobook format too. Now, next you would do is you'd open the tab by clicking on the button that's shown there. A 30,000 foot level chart will now be created for the original P-chart data set, which looks like this. And this particular data set is available and referenced in the book as in chapter 13-01. So this is what the app would look like when you open it. You would click on, first you would click on and browse to select your appropriate format, Excel, spreadsheet that you can access by way of your computer. Number two, what would happen immediately is you get a snippet that shows the information in the upper left-hand corner of the spreadsheet. The third thing what you would do is you would enter the various values that I'm showing here for the options that we have for entry to this particular app. Once you complete that, then what would happen is you get the figure, the 30,000 foot level chart appears up in the right-hand corner. Now, if you were to right-click on that image, you can save that as a PNG file. Number 5, the free app webpage that I described earlier provides more than 10 video instructions and other instructions for how to use this app for various data sets. So this is just one situation, but we can look at continuous data. We can have for normal distribution, non-normal, and so on. So it's a very powerful app, and the instructions show you how to use the app for various situations. So this is what our 30,000 foot level report looks like. Notice how we've got prediction statement at the bottom. If this prediction statement is unsatisfactory in our mind, then we need to have process improvement. Note how this is very different from the traditional control chart that we had that's shown in the upper right-hand corner, where we're tendency to fix all these problems that appeared as special cause. But in reality, there was variability between the subgroup, and the binomial distribution for the P chart was not valid. But notice how if for number 2 here, for a 30,000 foot level, we're going to be focused on process improvements. But we get very different actions from how we present this information, whether it's a P chart or if we get a 30,000 foot level report of the metrics. That's a big deal. Now, as I mentioned earlier, you can get to this app, and I said that there's like over 10 videos on this app that describes various situations that you can encounter when using this app. 30,000 foot level reporting provides one chart for process stability and reporting, easy to understand wording, percent non-conformance, I'll put that be easier. Prediction statement that encourages process improvement when a futuristic statement is undesirable. Or consistent reporting for continuous and attribute data, where we're looking at the percentage of non-conformance for a stable process. Where continuous data, we often looked at CP and CPK and so on, where I'm suggesting for a 30,000 foot level reporting of continuous data, you would just have, if you have a specification, estimated non-conformance rate, which is a lot easier to understand than CP and CPK and process capability indices. Number 5, 30,000 foot level capability indices, like I said, are much easier to understand than CP and CPK and so on. Process chain demonstrates by way of a staging of an individual's 30,000 foot level chart. Organization, consistency, and reporting. So you don't have north wing of the building reporting metrics one way and the south wing of the building reporting a different way. Process improvement when a 30,000 foot level prediction statement is undesirable. 30,000 foot level reporting comes from, consider like if you look out the window of an airplane in flight, the terrain below, you get a high level perspective of what's happening below. So that's, I come up with the terminology 30,000 foot level reporting. Now, when you do this, you can have a 30,000 foot level metric, which could be look like an individual's chart here, okay, the one shown on the left. And then if we don't like the answer, we want to improve it, then we can go in and use a Lean Six Sigma to make process or another process for that matter. So then you follow this particular roadmap and say you came up with some things that you believe improved it and you implemented those. Now, if you're successful, then that individual's chart would be staged to an enhanced level of performance. Now, in this case, I'm showing then we could look at what the bottom line benefit would this be in terms of money. So this would be how the attribute response would look like for a 30,000 foot level report. Now, we do also have a clickable Lean Six Sigma to make roadmap that's available through the link that's showed there, a website/roadmap. Now, if you look at the drill down of measured, you'll notice I have a lot more sub-steps to the measure phase than what's traditionally presented in a Lean Six Sigma to make roadmap. Find, measure, analyze, improve, control. The reason I did that because I tried to model my roadmap after what GE did in the 1990s, where they had part of the measure phase flow charting and FMEA and other tools like that, which I didn't think were truly not measures. So I created an additional drill downs from this. Now, one of the drills down is measure baseline for the project. And basically that measure baseline for the project is what that 30,000 foot level app will provide for you. So it's quite easy. If you click on a drill down of that particular website, the web page, then what you'll see is step 3.2 and 3.3 is basically what that app provides, a free app that you can actually use with no charge. The 30,000 foot level app can show again process improvement change. You can see how the individuals chart that I used to create the monitoring the failure rate over time. Notice how it dropped to about 4.3, and the prediction statement is using the data from the recent region of stability. So basically the last 3 data points. It does not consider all the data points before it was staged, this particular process was staged. Now let's look at a different situation where we got infrequent incidences. Now notice these are failures, but for example, we might have safety, where we have injuries in a company because of a safety event. Hopefully they don't occur very frequently. Okay, so how do we look at that? Well, I'm going to look at an example that I 13-03, which is in Integrated Enterprise Excellence Volume 3. This is what the data set looks like. You can see a lot of months we don't have any failures. Well, that's good that we don't have failures, but it makes it hard to analyze. So what are we going to do? Well, let's think about the traditional way of doing this. So from a continuous or attribute data decision point, we would select attribute. From the decision or defective decision point, we would select defects, not defectives like we did previously for a P chart. That is, we are counting the number of instances that occur in a certain period of time. Now, since we have a constant area of opportunity, in this case month, that would lead us to a C chart selection. So let's examine a C chart. The traditional C chart approach for this data set is to create, like I said, a C chart. However, the C chart is not informative since there's so many months that had no safety incidences. So now if we go in and look at my forest favorites again, but this time, instead of hitting P chart issues and resolution, we're going to do C chart issues and resolution. Now this is a page that we get if we would click on that particular link. Scrolling down, now we can see again the 2 different mathematical relationships that we have here. The top one be for traditional C chart. Notice how now we have the variation is within subgroup again, just like the P chart. And notice for the 30,000 foot level chart that is shown below, it's doing off the moving range. And so therefore it's going to have between subgroup variability, so they can look quite differently. Now, in order to do this, we have to go in and do things differently. Well, instead of reporting the number of failures per month, we want to report the time between failures. We track the days since last failure is a continuous response. You can see the time for failure number 2 on the table on the right it was 73 days since the last failure, failure number 1. Now, we couldn't plot failure number 1 because we don't have another in the base firm. So we have to start with failure number 2 all the way up to 21, and we're looking at the time between the failures. So the only time we can put a point down here is if we have a failure on this particular table. So if we're going to look at this, we now change our response from an attribute, really change it to continuous response. So now, if we did that, we come back and look at our 30,000 foot level chart, we'd actually have 3 different entries here. But I'm going to so let's look at the first entry here. So this would be incident sequences on the x-axis, and the vertical axis is days between incidences. So we can see we got a stable process here. Then what we're going to do with it? Well, now we want to do a probability plot of all that data. So we're taking all the individual data and we're plotting that out. So you can see we've got 20 or 21 points here. And then for each data point, we have a particular y-axis entry. Now, notice how this follows a straight line. So that indicates that a normal distribution is appropriate. Now, if we don't have a real specification for this, we then look at the 10 and 90% values and look at the x-axis associated with that. Notice how 10 from 90 is 80. Then we make a statement at the bottom that says, hey, our mean, we got a mean is 84, but we got 80%, that's 90 minus 10, between 50 and 117 days do this. Now, secondly, we could say we could divide 84 into 1 and we get 0.012 failures per day. That's our estimate here. Number 3, we noticed that the process improvement efforts were process improvements effort or next taken to increase the time between safety instances. So we wanted to basically improve this from just having a mean of 84 days. We wanted to increase that. So I didn't get the details of what was done, but we noticed number 1, there was a staging of the chart because now we can see that there was an improvement here. And now we look at the bottom and we say, well, now we got 113 days between it. Now, if we compare them, we can see it's quite different looking. It would be very difficult if we used the C chart to try to see if we had any type of improvement. But if we're looking at as time between incidences for this infrequent occurrences of failures, then the thing is we can actually identify when the process changed quite quickly. So additional information. I suggest that you check out these free articles, which also includes an informative video about 30,000 foot level and its reporting. I believe volume 3 has over 100 examples and 250 exercises on organizational measurements and improvements. The 2-book bundle provides solutions to these examples and exercises. The IEEE system is another approach that provides a vehicle for organizations to management that can have automatic updates at 30,000 foot level metrics throughout the business. So as a wrap up, please submit your questions that you might have about the content that I covered in this session here. These 2 books are available in novel book format, in paperback, ebook, and in audio formats. Again, I have a passion for showing people how to apply and benefit from a free 30,000 app for their data set. So let me know some good times for you to have a half-an-hour session where we can work together to look at how you might apply this. There's a schedule, a video session with me linked near the bottom of the website noted there. So again, a copy of this PowerPoint presentation and recording of this webinar you can send your request to me at the email address shown there. So Melanie, is there any